This is section 12.2, arithmetic sequences and series. We're going to begin with looking at an arithmetic sequence, and then we will identify specific and general terms of the arithmetic sequence. So a sequence, A sub n, in which each term after the first differs from its predecessor by a fixed constant, and we're going to call that constant D, and that D is called the common difference. That is the definition of an arithmetic sequence. And we can find D quite easily by taking the future term minus a previous term. So we will be able to tell whether a given sequence is arithmetic or not by looking to see if we can compute a common difference. So in number 1 and number 2, we're going to determine whether the sequence is arithmetic or not, and if so, we will find D. So looking at number 1, we'll go ahead and just take a sub 2 minus a sub 1, and that's 3 minus 1, and we come up with 2. Now let's look at a sub 3 and subtract a sub 2. And as you can see, that's different. These are not the same. So this is not arithmetic. Okay, let's go ahead and take a look at number 2. As you can see, we have a sub 2 minus a sub 1 is 9 minus 4, and that's 5. A sub 3 minus a sub 2, 14 minus 5 minus 9 is 5. And we could go ahead and see a sub 4 minus a sub 3, and we have 19 minus 14, and we also get 5. And then you can see the difference here is 5. So this is a yes. Okay, now let's come up with an arithmetic sequence. Here we're going to write the first 4 terms of an arithmetic sequence with first term -2 and D equal to -3. So let's write that down. A sub 1 is equal to -2, and D is equal to -3. So A sub 2 must be equal to -2 plus that difference, and that would be -5. A sub 3 is going to be a sub 2 plus that -3, and we'll come up with -8. And then a sub 4 will have -8 plus that -3, and we'll have -11. So we could actually write our sequence as -2, -5, -8, -11, and so forth. We could actually write it like that. Okay, now we're going to find the nth term of an arithmetic sequence. And the nth term is given by this formula. So we'll begin with the first term. And whatever that value of n is, we're going to subtract 1 and then multiply by that common difference. Okay. So find the 23rd term of this given arithmetic sequence. So let's first write a few things down. We do see that we have a sub 1 is -8. And it's pretty obvious that the difference is -3 minus -8. So that's -3 plus 8. So we do have D equal to 5. So to find the 23rd term, a sub n is going to be a sub 1 plus n minus 1 times d. So if we're looking for the 23rd term, we'll take that first term and then we'll multiply our difference by 23 minus 1. So if you work that out, you will come up with the 23rd term is going to be 102. Okay, let's find the 40th term of an arithmetic sequence in which a sub 1 is 12 and a sub 11 is negative 38. We need to first find d. Then we will find a sub 40. So let's use our given information. We have that if a sub 1 is 12 and a sub 11 is negative 38, that is when n is equal to 11. So remember our equation, a sub n equals a sub 1, n minus 1 times d. So a sub 11 is going to equal a sub 1 plus 11 minus 1 times d. So we have negative 38 equals 12 plus 10d. So we have negative 50 equals 10d, and d is negative 5. So now that we have d is negative 5, we can do the same thing over in order to find a sub 40. So now a sub 40 is going to be a sub 1 plus 40 minus 1 times negative 5. And that's negative 183. Okay. Now, let's find the number of terms in the finite arithmetic sequence. So if we have a finite sequence, we have a countable number of terms. So let's see what they've given us. They've given us that a sub 1 is 3. We also know that d is equal to 5. That's pretty obvious. And that last term is 98, but we need to find n. Okay, so what we can do is we can say that, let's write our equation down, a sub n is a sub 1 plus n minus 1 times d, and we'll have 98 is equal to 3 plus n minus 1 times 5. So we'll subtract 3 from both sides, and then we'll divide both sides by 5. So now we have 20 equals n minus 1, and n is, let's see, 20. Whoops, that should be 19. And then adding 1 to both sides, we have n is equal to 20. So we have 20 terms in this sequence. Okay, Edward in number 7 has a savings plan. He starts by putting 1 dime in his piggy bank. Well, you know what? I'm going to just write a sub 1 is 10, and we'll just use cents. And he plans to add a quarter to it each week. So it looks like D is going to be 25. Write the nth term of a sequence defining the amount of money Edward has in his bank. So with this, we know that a sub n is a sub 1 plus n minus 1 times d. So a sub n is 10 plus n minus 1 times 25. We can simplify that. We have a sub n equals 10 plus 25n minus 25. We just distributed this 25. And then we have a sub n is equal to 25n minus 15. And that is going to be the nth term. And that defines the amount of money Edward has in his bank. How much money will Edward save in a year? Now, remember that we had n as weeks, because here this says each week. So here n is equal to weeks. So in a year, that will be 52 weeks. So a sub 52 is 25 times 52 minus 15, and that comes out to $12.85. Now keep in mind that's cents, so he will have $12.85. Okay, now let's take a look at a finite arithmetic series. And also we'll be looking at the nth partial sum. So we'll be finding partial sums. So the sum S sub n of the first n terms, so we're adding the first n terms together. And that's given by this equation right here. So here, if you can see, this is the first term and this is the nth term. And that n and this n are the same. So let's try one. Find the sum of the first 25 terms of this given sequence. Well, as you can see, we have a sub 1 is 3. And we can also see that d is equal to 4. So the nth term, let's write our equation down. A sub n is equal to a1 plus n minus 1 times d. So we have a sub n is equal to 3 plus n minus 1 times 4. And let's simplify that. That's a sub n equals 3 plus 4n minus 4, and we come up with 4n minus 1. So that tells us that a sub 25 is equal to 4 times 25 minus 1, which is equal to 99. So we needed that for this equation. S, and we wanted the sum of the first 25 terms. S sub 25 is going to be 25 divided by 2 times our first term plus our last term. And if you work that out, you'll have 1275. And that is the sum of the first 25 terms. Okay. And I can write that equation here. We had S sub n is equal to n divided by 2 times a sub 1 plus a sub n. And in our case, a sub n was going to be a sub 25. So we do need that nth term. Okay, Looking at number 9, they've asked us to find the sum. As you can see, we have a finite sum, the first 22 terms. Let's just write down what this means to make sure that you understand this. K is equal to 1 when we begin. So our first term is 8 minus 5 times 1. And then the next term is 8 minus 5 times 2. And so forth all the way until we get to 8 minus 5 times 22. So as you can see here, a sub 1 is 3. A sub 2 is a negative 2. And then we have a sub 22 is a negative 102. So that's 110 minus 8, a negative 110 plus 8. So now what we can do is we can first find the difference, that common difference, which is A2 minus A1, which is negative 2, minus 3, which is a negative 5. And now we can come up with S sub 22. That's going to be 22 over 2 times A sub 1 plus A sub 22. So we have 11 times 3 plus a negative 102. And if you work that out, you will have negative 1089. So these are kind of fun to work with. Just a couple formulas and pretty straightforward after that. Okay, now let's look at some applications with arithmetic sequences and series. An outdoor amphitheater has seating in concentric semicircles such that the first row has 11 seats, the second row has 16 seats, the third row has 21 seats, and so forth. Let's write that down. They're giving us a sequence, 11, 16, 21, ... If there are 24 rows of seating, how many seats are in the last row? So really what we're looking for is this. So let's write some things down. It's obvious that A sub 1 is 11, and our common difference is 5. So we have A sub n equals 11 plus n minus 1 times 5. And we do have that A sub n is equal to 11 plus 5n minus 5, and A sub n is equal to 5n plus 6. So now, if we have 24 rows of seating, n is 24. So A sub 24 is 5 times 24 plus 6. So A sub 24 is 126. So 126 seats. Okay, looking at number 11, Donna must choose between 2 job offers. The first job pays $60,000 with a raise of $2,500 for each year thereafter. Looks like we're going to be looking at the first job and the second job. So let's just go ahead and get that written down. And it looks like A sub 1 is $60,000 for this job, and then that common difference is going to be $2,500. Okay, for the second job, pays $50,000, and that common difference is going to be $3,000. And all of these are dollars. And I should have written A sub 1 here. Just move that. Okay, so now they ask us, if Donna plans to stay at the same job for 20 years. So here we have n equal to 20. Which job is the better offer? So we need to find a sub 20 for each offer. Okay, so in the first, and I'll just put a little line between these so we know we're working two different scenarios. We have a sub n is equal to a sub 1 plus n minus 1 times our d. And now we come up with this nice formula for a sub n. So to find a sub 20, we would have 2,500 times 20 plus 57,500. And this comes out to 107,500. So this would be $107,500. Okay. So now let's look at the second in the same way. And then we'll compare them. And that would be $47,000 there. And then we will use this formula to find a sub 20. So we have 3,000 times 20 plus 47,000. We come up with 107,000. And as you can see, the first offer is better. Okay, if Donna plans to retire from the same company after 30 years, which job should she take? So let's see what happens after 30 years. So the first offer, a sub 30, is equal to 2,500 times 30 plus 57,500. And if you work that out, you'll have $132,500. And the second offer will have a sub 30 is equal to 3,000 times 30 this time plus 47,000. And here we will have $137,000. So now this time this second offer is better. Okay, and that concludes this section.